For our last speaker today, I would like to call upon Dimitri Piroulis, the Burke Head of the School of Electrical and Computer Engineering and the Riley Professor of Electrical and Computer Engineering. Dimitri, over to you.
Thank you, Arvind. It's a pleasure to be here, and it's my distinct pleasure to introduce Shreyas Sen. I want to start by saying that we in ECE are really blessed to have Shreyas in our school. Shreyas actually got his PhD from Georgia Tech. He also has 5 years of industry experience. He has worked with Qualcomm, Intel Lab, and Rambus. His current research is in the area of mixed signal circuits and systems, electromagnetics for Internet of Things, biomedical, and security. Shreyas is actually the inventor of the electro-quasi-static human body communication, for which he actually received the MIT TR35 India Award. His work has actually been covered by over 100 news releases. He has made appearances in radio and TV shows. He has appeared in TEDx Indianapolis and other places. He has a long list of significant awards. He received actually this year in 2020 the NSF Career Award, the AFOSR Young Investigator Award in 2016, the NSF SAIS Award in 2017, the Google Scholar Faculty Award, and so on and so forth. He has received actually 7 Best Paper Awards, which is actually incredible for somebody who has just gotten tenure. He has co-authored 2 book chapters, over 135 journal and conference papers, and he has 14 patents, either granted or pending. If you're wondering if he's finding time to get involved in other things, yes, he's a fantastic mentor for our undergraduate students. He's been a pioneer in developing online courses. He's actually a founding faculty for the Intel Purdue Design for Security Badge program. And I could go on, but I think you really want to hear from Shreyas. So let's welcome Shreyas. Go ahead, Shreyas.
Thank you, Dimitri, for the very kind and generous introduction. Let me share my screen. Am I audible?
Yes.
Okay, very nice. So today I'm going to share with you my journey, my life journey, which eventually led to the invention and impact of body as a wire technology, and how it has been fulfilling in teaching and mentoring undergraduates in the process. I'll start with a brief overview and then focus on the topic. And I'll try to keep it high level. And of course, if there are detailed questions, I'm always happy to dive down when time permits. So first of all, I direct the Spark Lab. These are my students who do all the work. So I want to start by thanking them. And here are all the funding agencies, some of which might be joining the call right now. So thank you for trusting us, and thank you for all the students for doing all the work that I'm going to share. Our work typically spans in a few different areas, but focused towards this central theme of secure and efficient Internet of Body. I'll define these terms, which includes communicating through the human body and making sure that the devices we have on the body, like the sensor nodes or the computing nodes, are secure from an electromagnetic hardware security perspective. The intelligence that goes into it, and developing biomedical sensor nodes and neural sensor nodes, as well as intelligent radios. So all of which again combines towards, you can think of sensor nodes that goes onto the body that are secure and efficient. In today's talk, I'm going to focus on this, the first topic, electroquasi-static human body communication, or in other words, body as a wire. To start my life journey, my mom tells me that from childhood, I grew up as a very curious kid. That's me at 2 years old. And by the time I reached grade 4, I was making and breaking things a lot. And I started experimenting with even frogs way before my time it was due in school. So that making and breaking nature led me to, at the end of my high school, to the top engineering and the top medical school in my state. And I was at a junction of making a choice. I was so naive that I wanted to do both to get a test, but of course that was not possible and I had to choose. I chose engineering, but kept my desire to combine this at a future time when it is more opportune. During engineering in undergraduate, this is when my life formed because of the undergraduate research experiences that my professors provided me. At Jadavpur University, where I did my bachelor's, I was involved in over 4 research projects. Simultaneously, in the last 2 years of my bachelor's, I used to travel 3 hours to go to IIT Kharagpur, from where I did my bachelor's thesis. And simultaneously at IIC Bangalore, I got into the Young Engineering Fellowship Program and did a research internship. So during this undergraduate, I got a chance to publish over 5 papers, which is at that time was pretty uncommon. And that basically got me hooked to the adrenaline that happens when you think about new problems and come up with a cool solution, which kind of unknowingly already decided my path for the rest of my life. Then I went for my PhD to Georgia Tech, where I was looking into intelligent radios that can behave like humans and adapt. Because I was so hooked to research, after my PhD, I still decided to stay in industrial research in Intel labs. After 5 years at each of those places, I was ready to take on a more academic freedom kind of a role and came back to West Lafayette. And I was thinking, okay, how can I utilize my knowledge and understanding that I have garnered? And I started looking for new problem areas. And that's what I'll explain next. So how many of you use a wearable like a smartwatch or a earpod? I'm sure many of you. How many of you or people you know uses medical devices like insulin pump or pacemakers? That should be quite a few also. These devices on your body or in your body creates a network which is a subset of the more commonly known Internet of Things and is called the Internet of Body. The key thing, distinguishing thing for this Internet of Body devices is that all of these devices are on or in your body, so they have a common medium that is your body itself. And one question comes, are these devices secure? So there's a famous story that US Vice President Dick Cheney was very scared that his pacemaker would be hacked and asked his doctors to disable it. And this was depicted in the Broken Hearts episode of the Homeland TV series, where attack of the pacemaker was shown from a remote place. Now, these are not only stories. Famous hacker Barnaby Jack, between the year 2011 and 13, showed that insulin pumps and pacemakers can be hacked in live audience in front of many people in a conference on a mannequin as well as a human being who was his friend. So these things are still out there. You know, these vulnerabilities exist in pacemakers that people already have. I don't want to scare you, but this is 2019 releases from Department of Homeland Security and FDA showing wireless communication vulnerabilities in pacemakers as well as insulin pumps. So let's try to understand why this problem happens. Today, when I try to communicate from one device on the body to another, for example, let's say this person is trying to communicate from his watch to the pacemaker. What happens is I take the information, digital information, put it on an electromagnetic carrier, which then radiates all around us, goes in all directions. And in the intended device, I only pick up a very small fraction of it, which means my signals are not only going to my intended receiver, but going everywhere. And somebody in sharing the common space, like a Starbucks size coffee shop, can hack into your signals if they're advanced hacking skills. That creates a big problem. So I try to think, what can we do about it? And of course, armed with the freedom of academia, I also had 2 key insights that at Georgia Tech, I was learning about wireless systems, where I learned that it is great for connectivity. It's very ubiquitous. But because the physical signals are present, you can hack these things if the encryption is broken. At Intel, I was working on communicating through wires, and I was part of the team which pioneered the USB-C type connector that you use today in many devices. And what I learned is communication through wires are like 100 to 1,000x more efficient because the signals are content, and also because the signals don't leak out, these are physically secure. And this was because I had the freedom, I wanted to combine my long-term wish to work at the junction of engineering and medicine. So I tried to solve this problem for medical device connectivity by applying the knowledge and the difference between wireless and wireline communication. And I asked myself the question, can we use the human body as a wire? When bodies connect, communicate through the body, or even on the one body itself between two devices, why not communicate through the body? And turns out the body is somewhat conductive thanks to the high water content. So me and my students dove deep thanks to the Air Force Young Investigator Award, which led us to the basic science. And we tried to model the body as an electrical circuit. And for the first time, we came up with such electrical circuit models, and the outcome of which became that human body can be modeled as a circuit, which led to certain ways of exciting and terminating it, which led to the invention of electroquasi-static human body communication, or in simpler words, body as a wire. Here is a quick snapshot to help understand what's going on. So you can think of the x-axis is frequencies, where this is megahertz range and this is gigahertz range. This is where today's Bluetooth and other 2.4 gigahertz is there. So existing technologies work like this, that the received signal becomes more, and that because the antennas become more efficient for a small device, and it peaks around this range. So this lower frequency range, where the body acts as an electrical circuit, is called electroquasi-statics, and typically is unusable because the high loss in this range. By understanding the body as a circuit and using our patented technique, we were able to reduce this loss by over than 100x, which opened up a whole field of communicating and powering through the human body and even in the brain. And that has many, many applications as I will show next. So what does this mean? It means because we are using the electrical frequencies, electroquasi-static frequencies, the signal doesn't leak outside the body, unlike Bluetooth, where it goes up to greater than 10-meter range, making it physically secure, so hackers cannot snoop on your signal. Also, because I'm using lower frequencies and the signals stay within the body, it doesn't leak, the energy required for communicating is more than 100x lower compared to the energy of Bluetooth. So think about the possibility of body patches, which eventually become battery free. So we armed with these benefits, we try to see where the application lies for this technology. And there are plenty. In future, people are talking about closed loop connected healthcare, which also another word is bioelectronic medicine, where you would have closed loop electrical impulses given to the body, which replaces pharmaceuticals. And these need connection around the body, and EQS-HBC is the best known technique for that. There are many wearable devices which are emerging, as you can see over here, and all of them typically use Bluetooth, and BodyWire can provide 100x more efficient and secure alternative to it. Because you can send signal through the body, now your touch becomes more powerful. Along with the touch, you can send more information, and imagine all that you can do with it. And eventually, the concept of electroquasi-static communication through a medium is not limited to the body itself. People, recently, Neuralink had a great demo. People are trying to communicate from implanted nodes to the outside, and the brain medium can be used for such electroquasi-static communication, opening up very new applications. And we have some results for this already. So in summary, this new technology, which came about by combining my 2 5-year experiences and understanding the key difference between things and combining my love for biosystems, was widely recognized because in 2019, when the Department of Homeland Security came up with the advisory, around the same time our paper was published in Nature Scientific Reports, And IEEE Spectrum said that Medtronic discloses vulnerabilities, and can the Purdue technology solve it? Led to the MIT Tier 35 India Award, TEDx, CNBC TV interview. Some people said scientists design the network that lives inside the body, and somebody went to say that it demonstrates a huge leap in medtech data security, which is here to stay for a long time. So this technology is getting some traction now. Body-aware technology is getting commercialized through large companies and startups. AFRL is exploring it for military use. Different organizations, including IEEE Spectrum and Silicon Flatirons, which was organized by DoD and Colorado Boulder, said that this is a possibility for the future of body-aware network. Several news coverages and covered by many publications and awards. Now, I want to say that all of this happened partly because my professors in undergraduate hooked me to research and showed me what fun research can be. And that has always been because that was a turning point in my career, it has always been my wish to make undergraduate students see the same. And fortunately, I got the chance to teach large undergraduate class over here, and over 1,000 students I have interacted in person, to many of which I took the opportunity and in one class showed what research could be for 5 minutes. And that had led to hundreds of discussions. And over 30 students have worked with me for at least a semester or more. Some of which have led to first author publications by undergraduates and have led to graduate degrees at Berkeley or continuing a PhD at Purdue. I think David is here, who I'm mentioning, and many undergraduate summer interns. So with that, I'd like to acknowledge everybody without whom I would not have been here. First, my family, my mother, my father, and my wife for all continuous support and grooming me into who I am. My teachers and professors for instilling in the curiosity and love for research in an early age. My mentors and colleagues at Intel and especially at Purdue, where I have found it to be a very great place to do work and getting mentored by everybody around. Funding agencies who have put our faith and providing the opportunity. And finally, but importantly, the students with whom the discussions is the most exciting part that guides my day. With that, thank you for the opportunity for sharing my journey.
Thank you so much, Shreyas. That's wonderful. Yet, due to lack of time, I'm going to jump immediately to the first question here. One question in the chat says, if you can comment a little bit on how you balance the entrepreneurial potential and tenure track demands.
That's a great question. If you think your technology has entrepreneurial potential, the first thing one should do is file a patent. Purdue OTC and PRF is extremely helpful in that process, and I have filed many. I have like 4 or 5 patents that is filed. Then it becomes an interesting question. You are on a path where you are exploring so many things. Are you the right person, or are you in the right phase of your career to become a CEO of your company? Often the answer, sometimes the answer could be yes, many times the answer could be no. And it's fine, to me at least, it's fine if the answer is no, because what I care about is this technology getting to people's hand and impacting it. And in that case, finding somebody to do the CEO role of your company while you provide the technical guidance helps a lot. Hope that helps.
Wonderful, thank you. Maybe we have time for one more quick question. Then, yes, we have a question from Alice.
It's the same question. I'm always interested in how different people answer it. So if there was one lesson that you were taking away from your pre-tenure time, what would it be? Thank you.
Yeah, I expected that you will ask that. And I was thinking, already people have said such nice
I didn't want to leave you out,
Right. What can I add? But I think I can add something. My experience is before professional development comes personal development. So if we look inside and understand what is the one reason why I am here and what I really care about, what is my passion, then and articulate that passion to important people, your mentors and your funding agencies, then everything I feel falls in place. Because everybody is here to empower you. If you can say that this is my vision, like Carlo was saying, first understanding your vision and mission, and then being able to articulate it, helps everybody else who wants to help you in a better way.
Shreyas, thank you so much for sharing your inspiring thoughts and directions here with everyone. Arvind, back to you.
Thanks, Dimitri, and thank you to everyone to come and listen to these brilliant and inspiring colleagues.